All right, lesson 10, multiplying radical expressions. Now this is kind of on the easier side in terms of definitions, okay? I'm not going to say that the work is going to be super easy, but at least in terms of definitions, this can be kind of simple, okay? Here's the main definition you have to know, okay? If you have nth root of A times the nth root of B, I want you to notice that the indices match for the root. It doesn't matter if the radicand matches. In other words, the A and the B, they don't have to match. But as long as the indices match, okay? So square roots, cubed roots, fourth roots, as long as they're the same type of roots. So if that's the case, then you can combine them together by multiplying them out, okay? A times B. Okay, that is the definition that you need to know about multiplication of radicals. So let me show you examples. So example number 1, we're just gonna simplify here. So part A, the first couple are gonna be pretty easy. So notice how these are both square roots, okay? Square root of 3 times the square root of 7, since they have the same index, okay? I know we don't see it, but there is an index of 2 there for both of them. Okay, if they have the same index, then you just basically multiply the numbers and keep the same radical, okay? So it's a square root of 21, and that's it, we're done. Okay, so that one's finished. Okay, part B. Let's try doing something like this. So square root of 2b squared times the square root of 4b to the 7th. Now, just a word of caution for you guys, okay? If you want to make this a little bit easier on you, and you don't have to do this, but you could try to simplify things before you multiply, because then if you start to multiply, then your numbers get bigger and bigger and bigger. So it might be better to simplify first, okay? Now the square root of 2b squared, I notice there is an index of 2 here, okay, for both of these. So that means that this b squared part can actually go out. So let me write that out right here. This will be a b square root of 2 times. Now I know what the square root of 4 is. Okay, that's a 2. Okay, and then the b to the 7th, let me take an extra step here. Okay, I'm going to write it as b to the 3rd squared. That's b to the 6th, and I need one more b, so I'll put times b there. Notice the index, not a 3, I don't know why I keep putting 3's there. The index matches this power. That means a b to the 3rd can come out. So this is b radical 2 times 2b cubed radical b. Okay, that b to the 3rd was able to come out because the index and the power match. Remember, we talked about that in one of the previous lessons. I think it was 2 lessons ago, that if the index equals to the power, then the radical will disappear for that term, and it just becomes whatever the term happens to be. So in our case, b to the 3rd. Now, in multiplying, all we have to do is combine everything. So the numbers on the outside get put together. So b times 2b cubed, that's 2, oops, sorry about that, using the wrong color here. That's 2b to the 4th. And then radical 2 times radical b is just radical 2b. And that's my answer for that one. Okay, so 2b to the 4th times radical 2b. Okay, now let me do another one. We got like 2 more that are very similar. So let's do these other 2, and then we're going to jump to a different type of problem. So let's do this one, the square root of 20x squared w times the square root of 5x w to the 6th. Now remember what I told you guys. You might want to try to simplify before, okay? Because or else 20 times 5, I mean, you might say, oh, well, that's 100. I can do that. Well, that's great. We can do that. Let me do this one without simplifying first, okay? And just because it might look like it's going to work great here doesn't mean it's going to work great for everything. But you could just multiply first. You could just simplify first. That's up to you. Let's do multiplication first here, okay, before we simplify. So this is going to be the square root of 20 times 5, that's 100. X squared times x, that's x to the third. W times w to the sixth, that's w to the seventh. Okay, so you might say, oh, that came out pretty nice. Well, yeah, but you still got to simplify that, okay? So we know the square root of 100 is 10. So that's 10. And then we're going to put square root of x squared times x, that's x cubed, and then w to the third squared times w, that's w to the seventh. And remember, the reason why I'm doing this is because the index right here, this index, which happens to be a 2, okay, I'll put it right there, is going to match this 2 here and this 2 there. So it allows me to bring it out. Okay, the only thing that's going to remain inside of the radical is this stuff here and this stuff here, because they will not be able to leave. So let me go ahead and write this out. This is 10. The x squared is just going to become an x because that's what's going to leave, just the x. And the w to the third is going to leave. Okay, and then the rest of it is going to be square root of x w. Now remember, you could have done this by simplifying first or by multiplying straight through. It really doesn't matter. It's up to you. Whatever you feel is easier. Okay, what I did over here is for part A, I just multiplied. And then I realized I can't simplify, so I was done. In part B, I simplified first. Right? Because I thought maybe that might work best. Maybe it will, maybe it won't. We got to see. Okay, for part C, I looked at 20 times 5. I said, well, that's 100. So let me just multiply straight out because I know the square root to 100. So that's why I did it that way. All right, one more of these, and then we're going to jump to a different type of topic. So cubed root of 2w to the fifth times the cubed root of 4w to the ninth. Okay, so once we get to cubed roots, I know some people start to feel a little uneasy because they're like, man, I don't know all my cubed roots. Well, you know, we know 8, cubed root of 8 is 2, cubed root of 1 is 1, right? Cubed root of 27 is 3. Maybe I can write some of these down for you guys here. So 1, cubed root of 8 is 2, the cubed root of 27 is 3, the cubed root of 64 is 4, okay, cubed root of 125, we'll just go up to 5, is 5, okay, those are like the most common ones. All right, so let's see. What I'm going to do here, since they both do have the same index, I'm just going to multiply straight through. Okay, so this will become a cubed root of 2 times 4 is 8. W to the 5 plus 9, that's 14. So 8w to the 14th. Now, I know the cubed root of 8. That's 2, right? We just saw that over here. Cubed root of 8 is 2. So I know that's going to be a 2. So let me write that down. That's a 2. Cubed root of w to the 14th. I gotta make it so that it's something to the third power with the power of 14. So I know I can do like w, let's see, to the 4th to the 3rd, that's 12, and then I need 2 more, so w squared. So there you go, that's w to the 14th, and the great thing about it is that those match. That means that w to the 4th will come out, okay? So that's 2w to the 4th cubed root of w squared. So there we go. There's my answer for that problem. And like I said, I do want to kind of jump into something a little different. There's 3 examples of something that's a little different, but these are just multiplying radicals, but just the radicals themselves without using any type of distribution or anything like that. Now, for example 2, they are going to make us kind of distribute. Okay, so example number 2, we're going to simplify still, but they're going to look a little different. Okay, radical 3 times 8 radical 12 minus radical 11. Okay, now we're going to go ahead and multiply this stuff in. So radical 3, remember we're just kind of moving this way. We're going to do a distribution. Okay, so radical 3 times 8 radical 12, that would be 8 radical 36 minus radical 33. Now I know the square root of 36, that's 6, right? So this is going to come out. So this is 8 times 6 minus, and the square root of 33, well, there's nothing I can really do with that because it's just 3 times 11. None of those have a nice square root. So I'm just going to basically multiply this out and leave it alone. So there's my solution to that one. Okay, so all right, so you might say that's not so bad. It isn't really bad, but you know, sometimes they look a little intimidating. So look at this one right here. 4 radical 3 plus 5 times 3 plus 4 radical 6. So this you're going to have to do by foiling. Okay, you're going to do foiling for this problem. Remember, we're going to multiply first, then outer, then we'll go inner, and then last. Okay, so the first, 4 radical 3 times 3, that's 12 radical 3, because 4 times 3 is 12. Next, 4 radical 3 times 4 radical 6. Now 4 radical 3 times 4 radical 6 is 16 radical 18. Okay, inner, 5 times 3, that's 15. Last, 5 times 4 radical 6, that's 20 radical 6. Okay, so now we got to simplify. So we have 12 radical 3 plus, so I can't really simplify that one, but I can simplify radical 18. So 12 radical 3 plus 16 radical 9 times 2. I know that 9 can come out as a 3, so I know that. The 15 is just what it is, and the 20 radical 6 is just what it is. It can't do much, so let's go ahead and just try to rewrite this. So the 9 comes out as a 3. That's 16 times 3, that's 48 radical 2 plus 15 plus 20 radical 6. Now the last thing I got to do is check to see if any of my radicals have the same radicands and the same indices. Okay, the index. Now they all are square roots, so that's great, but none of them have the same index. So that means I'm done. I can't do anything else with this problem. I simplified it as much as possible. So that's it. I'm finished. Okay, now one more of these and then we're done. I'm just trying to show you guys what I saw on the homework. So that's what I teach off of. Whatever I see on the homework, I try to create examples very much like it so that you guys aren't shocked. Okay, unfortunately, the problems on the homework, they circulate. They're not all the same. So whatever I see may not be everything you're going to see. So I try to look at many of these things to kind of give you a good chance of understanding everything. So, all right, here we go. For this one, you see radical x plus 4 radical 2 squared. That basically means you get to rewrite this radical x plus 4 radical 2 times radical x plus 4 radical 2. okay? The power of 2 means write it twice. So that's what I did. Now I'm going to do FOILing again, okay? So we're going to multiply first, outer, inner, last. And then we simplify once we're done. So let's see, radical x times radical x, that's radical x squared. Okay, then radical x times 4 radical 2, well, that's a positive 4 radical 2x. Remember, the radicals, since they're the same index, you can multiply the numbers inside, so 2 times x. Moving on, the inner, 4 radical 2 times radical x, that's 4 radical 2x. So you might notice we have some like terms right there. And then 4 radical 2 times 4 radical 2, that's 16 radical 4. Okay, so let's try to simplify as much as we can. The square root of x squared, well, hey, since the index of 2 matches that, that means the x just comes out, so it's going to be an x. 4 radical 2x plus 4 radical 2x is an 8 radical 2x. And then that's 16 times 2, because the square root of 4 is 2. So this is x plus 8 radical 2x plus 32. I can't combine anything, so I'm done. So hopefully this stuff doesn't seem too difficult. If you're having any problems, please contact us. Let us know what's going on. Try to stay in constant communication. Hey, I get this, I don't get this. That way we as teachers can try to make sure that we're helping out as best as possible. So go ahead, if you want to review this, go ahead. If you want to look at the notes again, go ahead. If not, go to Alex and start your assignments. Have a good day.